Hello, and welcome. Thanks for coming tonight. You guys hear me okay? I see a lot of new faces out there tonight. All right. Thanks, guys. I appreciate you guys coming out. I hope you guys got some beer and some beverages and some snacks. Tide you over until we head over to the oyster bar for oysters, I guess. That's what they serve there. The oyster bar. So. I see a lot of, like I said, I see a lot of new faces out here tonight. How many people here are at their first Bitcoin meetup? Raise your hand high. Awesome. First in San Diego. Okay, great. How about first ever Bitcoin meetup? Awesome. That's a good amount of people. We've been getting a nice group every time so far. So we appreciate you guys making the effort. We know it's a Thursday night. There's other things that you could be doing with your time, and we think that this is one of the best ways you can do it because you get to learn, and hopefully your education will help you in your financial world as well. We know that right now everything is kind of in an uptick, so hopefully people who are invested in cryptos are doing quite well. I see smiling faces, no one's crying, so that's good. How many people here have an Airbitz wallet? Yeah? Okay, good. If you don't have an Airbitz wallet, that's fine, but you are here at Airbitz, so I suggest checking it out. It's one of the more user-friendly, ooh, sexy. One of the more user-friendly wallets, so I definitely suggest checking it out. And they're generous enough to sponsor the event here with us every month. And Constructive, which is my company, also helps sponsor the event. Also, Airbitz does what they call edge security, and so it's a security platform for sign-in for your customers, essentially. You can use their wallet to sign in on your platform, which allows you, as the developer or the owner of the website, to not have to hold passwords for people. So that's awesome. Yeah. See? User story right here. Use case. And so Constructive, my business, actually helps in the consulting space. There's a few cards over on the table there if you want, or you can reach me after the event. We do business development, so we help people and businesses with their go-to-market strategy. And our main vision that we try to express to people is it's really important that you become educated about this space so that you can make well-informed, confident business decisions, because without actually having the knowledge, you're pretty much just throwing your money or your time at something that you don't really understand, and which you could end up in a pretty bad spot. So everybody understands time is valuable, which is exactly why we appreciate you guys so much for coming out tonight. At the end of the presentation tonight, we will allow people to come up and they can do a 60-second pitch about their business or what they're working on. If they want to just introduce themselves to the group because they're looking for people, like-minded people or traders or people who are doing like large investing or whatever it is that brings you to this group, feel free to let everybody know so you can find more people. This is one of the reasons we host this. Twice we have 2 a month. One is a more casual event, and then the other one is usually a formal speaker. We want people to be able to network, so that's why we give people time to, meet and chat beforehand, and then afterwards when we head down the street to Oyster Bar. So tonight's guest is Paul from Swarm.market, and they're a local company here. So they've been coming to the meetups for a while. And we've seen Paul running around at events all over. So we're excited to have them here. They're a cybersecurity related platform. So it's really interesting play, something new that we haven't really seen much of in the crypto space. So without further ado, I'm going to introduce Paul of Swarm Market.
Hi, everyone. Thanks for coming out. This is a pretty great turnout, so I'm happy to talk to you guys tonight about our topic, smart contract insecurity. So there's been a lot of problems with smart contracts lately, built on the Ethereum blockchain. I'm going to talk about a few of them and why they are problems.
Not only Ethereum.
Not only Ethereum, right? Not only Ethereum. Although I will be focusing on Ethereum right now. So if you're here for the Tezos talk, that's next door. Yeah. So our background, my background, also Ben and Sean out in the audience. You'll see them with purple shirts on as well. Our background is information security. That's kind of what I call my day job. This is nights and weekends, and what we're trying to fix on the nights and the weekends are the antivirus, or we're trying to decentralize the threat intelligence market. So I'm going to talk a little bit about what we're doing at the end, but that's not primarily why I'm here. Primarily why I'm here is I'm here to bore you with a lot of technical details about some hacks and some vulnerabilities and some exploits that have cost people hundreds of millions of dollars. So this is a technical talk. I'll apologize up front if you were misinformed, but yeah, let's kick it off. Cool, so I'm gonna just repeat what I just said. Just kidding. No, just kidding. Okay, so this talk is gonna focus specific, there's a lot of vulnerabilities that can happen in Ethereum smart contracts, but so we have to scope it somehow. And the way that we're scoping this tonight is real smart contracts that were really deployed to the blockchain, that people really trusted millions of dollars to, that were really exploited. And yeah, so the juicy stuff. Next slide. What we're not covering tonight, we're focusing specifically on Solidity smart contracts. So if you've ever coded for Ethereum, the compilers you typically use are Solidity, Serpent, or Viper is coming up. Viper will be future work. There have been problems in the compilers themselves. We're not going to touch on those tonight. And anything involving the hacking of exchanges, things like that, hacking Mt. Gox, we're not talking about that. So let's move on. All right. So who here has heard of the DAO?
Lots of hands.
Okay, that's like 95%.
Let's actually look at the code of the DAO.
Sure. Who's actually looked at the code of the DAO? Okay. Fewer. So the DAO was what the SEC considered, in retrospect, to be a securities offering of tokens that would allow people to vote on how a decentralized autonomous organization would direct funds and develop products. So there was a vulnerability in their smart contract that implemented the DAO, and it cost them to the tune of $50 to $60 million. And the real interesting piece in all of this is the way that the DAO is structured. Those funds could not be realized for about 30 days after they were stolen. So there's a time period in which the Ethereum community tried to decide what to do about this hacker. As with anything blockchain, everyone disagreed, right? So some people thought that, hey, this hacker exploited code and the code is law. So the hacker should be able to keep that money. Those people went off and joined or started Ethereum Classic. The core Ethereum developers, Vitalik and et cetera, they said, hey, this is kind of detrimental to the long-term vision of Ethereum. We don't want this thing to kind of like bury us. So we're going to hard fork and remove all the funds that the attacker stole. So code is not law, right? Anyway, that's a very political topic, but so the core vulnerability here was the programmers of the DAO didn't anticipate a reentrant sort of control flow. And what I mean by that is if you have a smart contract, first of all, I'll take a step back. Who is familiar with Ethereum smart contracts. Okay, good. All right, that's better than maybe I was expecting. But so yeah, you deploy a contract to the chain, and you can pay gas. You can send transactions to that contract. That causes distributed computers around the world to compute that contract's code. And what makes Ethereum so cool for nerds like us is that that code can actually hold the keys to money or ether. So one thing that wasn't really well understood around the time that the DAO was being developed was if your trusted smart contract calls another smart contract, they didn't really understand what the implications of that were, in the sense of that other smart contract maybe calling back into you again. So the good smart contract calls the bad one calls back into the good one. So that's called reentrancy.
Wasn't the security audit?
I'm sorry?
The reentrancy attack was mentioned in the security audit before Ethereum was launched. So it was a well-known vulnerability.
Okay.
Slockit was just stupid enough not to.
So whoever's interested in these slides, there's actually a lot of links in the speaker notes as well. Slockit, the developers of the DAO, actually thought they fixed this bug as well. They fixed another instance of this bug, but they missed one, and they wrote a blog post on how they were invulnerable to this bug, but whoops. Yeah, okay, so at the core of it is basically you're doing dangerous things in a manner that a bad contract calling back into you can exploit. So it's if you don't handle it properly, it's unhandled reentrant control flow. So let's go to the next one and take a look at some code. Again, sorry if you weren't expecting a technical talk. But this is really just, this is the actual code from the DAO, and it's cut down. All the fluff taken away. But what happens here is the DAO calls this function, the attacker calls this function split DAO. And what that does is it creates two child DAOs. And those child DAOs are funded with parts of the funds from the parent DAO. Down here in number 2, we have in this line right here, it's actually going to call into the attacker's controlled contract their new child DAO, and then it's going to it calls in the attacker's one right here. Sorry, got that backwards. This is where it computes how much funds are going to go in. Anyway, so this is the part where it calls in the attacker's DAO, but the important part is, and here's where the vulnerability is, down here is where they readjust the balances. So they first call into the attacker's contract. Up here, they transfer funds to the attacker's contract. Down here, they zero out what the funds were. So what this means is right here, when they call into the bad contract, that bad contract can call back into this function at the top of it, get more funds, go down here, call into the top of it, and do that in a loop. And they never get down here. So they did this in a loop, and people could actually see them draining money out of the DAO in real time. So that's it in a nutshell. Get a little bit more into the weeds, but we'll move on. Okay.
What was really bad was a typo. The capital T versus the small t in transfer.
Yeah.
That was really what screwed it up.
All right. So here's this is not the DAO. This is a synthetic example, and just to illustrate the problem. And I stole this example from some of our friends at Trail of Bits. If you've heard of Trail of Bits, they're an information security company that's doing a lot of smart contract auditing right now. So if you have any needs for that, look them up. But so this is the vulnerable contract. This is the exploit contract, and the slides get less dense after here, so just bear with me. So this contract will, this one will call, again, this is the same vulnerability. It calls into the potentially malicious contract right here, and then it adjusts the balance. And over in the malicious contract, right here, if attack mode is on, it calls back into the vulnerable withdraw balance, and they withdraw more balance, and they go back and forth, back and forth, back and forth, until all the funds are drained. So that's unexpected reentrancy. I could go more in depth, but we'll move on. Okay, so who here has heard of Parity? It's a they offer a multi-signature wallet. Okay, a fair number of people. So I've got a coworker that prefers it over Geth heavily. It's so much better, yeah. So it's written in Rust. It's nice. It's very clean. It syncs the chain, the Ethereum chain, a lot faster than Geth. And it also serves as a wallet. But by default, it offers to create a multi-sig wallet. And the way that that's implemented, who's familiar with what a multi-sig wallet is? Okay, a fair number of people. So what a multi-sig wallet, I'll just explain it real quick, is you have X out of Y people need to approve transfers out of that wallet. And the way that that's implemented is with a simple smart contract that's deployed onto the chain. Okay, so Parity had a multi-sig wallet that people could deploy, and it had a bug in it. And that bug was pretty severe. Well, it's as severe as it could get. It allowed people to change the ownership of the wallet and then just drain all the funds. And I'll explain how that works at a little bit of a high level, but feel free to talk to me afterward and I'll bore you to death. But yeah, so in addition to that, it's a bit salacious. The person who allegedly stole all the funds that were secured by these Parity multi-sig wallets to the tune of, he actually stole 30 million, but he could have stolen about 200 million, wrote a blog post about it, and actually got really good feedback on his blog post. It was on Medium, so you know when you like something on Medium, you clap for it, and I think it's got several thousand claps, which I don't know what that means in the grand scheme of things, but hey, there you go. So he had a bad Tinder date, and he went home early, and he decided to steal everyone's money. So my colleagues and I are like, before this blog post came out, we were scratching our heads. We're like, okay, way more funds are secured, quote unquote, by these Parity multi-sig wallets than like 30 million. Why do you stop at 30 million? And our theory at the time was that, if you recall from the earlier example of the DAO, if you steal enough money, the community might just decide that you didn't steal any of that money and hard fork away from you. Right? There's an upper threshold to how much money you can steal and get away with it. Turns out our hunch was correct. That's what he said in his blog post, assuming the person who wrote the blog post was actually the person that stole everything. So okay, enough about this. Ends the Tinder portion of my presentation, actually. So now on to the boring technical stuff. So the way that this thing worked, and this is typically considered best practice, you have a very complex contract, and you want to break it out into smaller contracts and reuse those smaller contracts. And the reason why you might want to do that is if you have code that a lot of people are using, like an example, if a lot of people are using Parity to implement their multi-sig wallets, there's a lot of duplicated smart contract code on the chain. That's bad because it costs everyone money to deploy that contract, costs them gas to run that contract. So you don't want to do that. So Parity refactored their very complex wallet contract and split it into a wallet contract and a wallet library contract. And wallet library was designed to just be reused by everyone and deployed only once. It was supposed to be a cost-saving thing, and it ended up costing them a lot. The vulnerability here, and this gets a little bit into the weeds of Solidity, but Solidity, which is the compiler for Ethereum smart contracts, will not prevents you from, by default, I should say, by default, every function is public. It's callable by everyone. They fail insecure, they fail open. So you don't have to decorate your function at all if you want it to be callable by anyone. It's just assumed by default callable by anyone. Okay, they might change that in the future, but that's how it is right now. In addition to that, they do some delegate call thing that I'll get into in a second here. Yeah, let's go to the next one. So the problem is this wallet library that they split out from wallet, intending to save everyone time and money. Time is money. Was not protected, right? It was public because it had no decorator to say that it wasn't public. So by default, it's public. Anyone can call it. This actually wasn't a problem before they split it out. So these lines, this init wallet, what this does is it takes an owners array and then an init multi-owned actually assigns those owners to an internal array that keeps track of who can transfer funds out of this contract. So if you're an attacker and you own this owners array, then you own all the funds in the contract. Okay, so these two lines were actually in the constructor of the wallet contract to begin with, and the constructor would not have been callable, but by breaking this out into a library, it became callable. There's an additional slight complication here in that the only reason why this worked is the wallet's fallback function. In Solidity, if you don't name a function, it's a fallback function. It's called if you call an invalid function name. Okay, whatever. That actually delegate calls to the wallet library. So what the attackers were able to do, let's go one more. I think I have. Okay, well, I'm not going to cover that. I will talk to that in person, but that's kind of a dense slide. That's more for reference online. Let's go one more. Okay, so this is actually what the attacker sent. These are the bytes in two different transactions, and if you take a look at the slides, I have links to the actual transactions on Etherscan. But what he did, allegedly he did, is call init wallet on the wallet contract, which it ended up calling its fallback function, which did a delegate call into wallet library, which installed his address as the owner address of the target contract. And then he called execute, which is the function that you call when you transfer funds out, and he transferred all the funds to his address. So pretty simple. If there was like a unit testing case or something for that, they might have seen that. But yeah, so that was a big thing. And also, interesting sidebar. So he stopped at 30 million, but another reason why he stopped at 30 million is there was actually a white hat group, quote unquote, that stole the remainder of all these funds that were liable to be stolen by anybody. And they ended up, they claimed they refunded 100% of the funds that the white hat group refunded 100% of what they stole. So it was really interesting because there's a lot of people like intimately involved with Ethereum. I mean, that's good. That's good for the health of the Ethereum ecosystem. People put a little bit more trust in the ecosystem if there's these, white knights out there stealing everyone's money and giving it back. Right? I mean, it's funny, but if they didn't steal it, some bad guy would have. So that's there's no fellowship in the blockchain. So let's go to the next one. Okay, this one's funny and less technical. So we're out of the weeds in the technical. This guy on Bitcoin Talk decided he was going to make a pyramid scheme on Ethereum, and he wasn't the first one. In fact, he wasn't even creative. He copied a different pyramid scheme and renamed it. So there was a pyramid scheme called Dynamic Pyramid, and that's fine, whatever. People threw their money at it. Some made money. A lot of people lost money. But some other guy came along and he's like, hey, I can make a house cut too. I'm just going to take dynamic pyramid and rename it and call it Rubixi. What he forgot to do is rename the name of the constructor. So the way that constructors work in Ethereum is if you have a function defined in a contract that matches the name of the contract itself, that is executed once while the contract is being deployed onto the chain, and it's never callable by anybody. So you can do all the totally, critical functions in the constructor, like initializing, for example, who the owners of a contract are. Well, he neglected to rename the name of the constructor. It remained dynamic pyramid. So anyone could call that. Anyone could call his constructor. So let's take a look at some of the code here. This is real simple. So you got Rubixi as a contract, and he copied dynamic pyramid, which sets the creator to whoever calls it. And this would have been fine if this was named Rubixi, but he didn't change that. And then down here is where he can, whoever the owner is, can collect all fees. So here we go. The vulnerability is Rubixi does not equal dynamic pyramid, and the exploit is call dynamic pyramid and then drain the contract. So yeah, if you're going to develop a pyramid scheme, just, I guess, check that. I don't know. Or don't develop a pyramid scheme. Okay.
Do we know how much money it was like?
It wasn't anything in the millions. I mean, the people participating in pyramid schemes are, fortunately, not that wealthy, or they won't be for long. I don't know. Here's another fun one. This isn't so much stealing funds from somebody else. This is like a foot gun sort of scenario. So King of the Ether Throne, actually a somewhat interesting contract, still basically a pyramid scheme, but there's a little twist on it. So you have, at any time you have a reigning monarch, and anyone can dethrone that reigning monarch by simply paying a bounty that's, I think it's 150% of the previous bounty. And in doing so, they become the monarch, and they send some sort of consolation prize, I forget the name of it, but they send some sort of tribute to the previous monarch. So what it encourages is people paying higher and higher bounties and hoping that somebody comes along later, so it's definitely a pyramid scheme.
Where does the money go if they pay for the dethroning?
The money paying for the dethroning goes into the pot, yes, and then plus a certain percentage of the additional goes to the previous monarch. So the previous monarch gets all of his money plus a little bit of juice. And of course, the guy who wrote the contract also gets money. builds in a house cut, right? That's the only reason anyone develops Ethereum smart contract. At least if you browse Bitcoin talk, that's the vibe you get. So this is more of a foot gun scenario. It's not stealing money from anybody else, but it speaks to one of the hazards of developing smart contracts is that sends, which is the way that you might send Ether, can fail. And if you don't check for failure, you might just think you're okay and you're actually not. So what ended up happening here is people were using things like a Parity multisig wallet, which is a contract, and so they were the monarch, they became the monarch in this thing. When a new person came to dethrone them, they would try to send the compensation to the previous monarch, but because they weren't a bare address, they weren't an external address, and they were actually a contract, the send would fail because the fallback function in the contract they were calling consumed more gas than was available. So the previous monarchs just didn't get compensated, and people got upset and lost a bunch of money. And I think the guy was like, "You should have read the code closer or something." No, he actually posted a post-mortem. It's really interesting. They did a really good job on it, but and then they issued a new version of King of the Ether Throne. So let's go to the next one here. So I kind of already explained all this, but yeah, so you got, so I mentioned that the person who authors the contract also gets a cut. He's considered the wizard, right? The wizard always wins, and the king, the previous monarch, gets some compensation for being dethroned. Okay. So possibly even worse than that is doing a send and checking it, but checking it wrong. And one way to check it wrong is to throw when a send fails. And the reason why this might, and this is another synthetic example, so I guess I kind of lied at the beginning of this presentation about all these being real world examples, but so the reason why this is a problem is, take a look at this loop. So you got a bunch of investors, you don't really care what this is doing, but farther than, there's a loop and they're paying people in a loop. And if they fail, if that send fails to any particular investor in that loop, then the whole thing bails, right? So any unscrupulous investor could cause the other investors to not get paid by simply, when he's called in that loop, cause an error to propagate and have the contract throw, nobody else gets paid. So that's called griefing. Yeah, I put that up there. Anyway, so again, this is not like stealing money, but you're preventing other people from using the contract as intended. It's definitely a vulnerability, so go on. Okay, this is a funny one. So everyone's familiar with rocks, paper, scissors, and everyone's familiar that you have to reveal your play at the same time in rocks, paper, scissors. There's not many rules in rocks, paper, scissors, but that's one of them. If somebody says, hey, I'm rock, and then a few seconds later you can say I'm scissors, well, that person's dumb. But aside from that, it doesn't work unless you're revealing at the same time. Well, this game wasn't revealing at the same time. So what ended up happening is people, there was no secrecy to the plays. If you were running a full Ethereum node, you could see the pending transactions that people are currently trying to mine. And in those pending transactions are some unfortunate souls playing this rocks, paper, scissors game. And you could see that your opponent, in whatever game that you're playing in rocks, paper, scissors, you could see their play before it was mined. So of course you could play the correct play and just win. So let's go to the next one. So I have links to, again, I have a lot of links in here, links to the actual transactions where this happened. So the first guy says scissors, and you can see that. This is a blockchain. There's no secrets on the blockchain, right? And then let's go to the next one. Yeah, obviously. So rock beats scissors, oops. So people figured this out relatively quickly, but there were some, yes, I have a question.
That solves the problem.
Yes, so the comment was, why did he not require commitments? And that would solve the problem. And people then developed an improved rocks, paper, scissors, and it's the shining example of development on the Ethereum blockchain. No, I'm just kidding. But no, people added that. The immediate response to this, if you're not familiar with cryptographic commitments, is or commitments in general, that was a joke, is you can do something like, I'm going to bet rock, and concatenate the string rock with hunter2 or whatever your password is, right? And then hash that. And then you commit to that hash. And then once everyone is committed to hashes, you reveal what your password was, including your play. And if there's no collision vulnerability in the hash function that you're using, you're good, right? You couldn't have actually chosen scissors because you couldn't compute what that concatenated string would be to be able to forge the hash that you committed to. So anyway, let's move on. So that was a fun one. There's a lot more vulnerabilities, and I'm not going to dive too deep into them, but there's a lot in the slides. A lot of links. So Another fun one, I'll briefly talk about one. There was a roulette game. And roulette requires a certain amount of randomness. And randomness is a very difficult problem to do on the Ethereum chain. If you think about it, where are you getting that random data from? Everything's public on the chain. And there's not really trustworthy access to external data sources necessarily unless somebody builds them. So actually generating a secure pseudo-random number generator on chain is a very difficult problem. That being said, this guy developed, or girl, I don't actually know, developed a roulette game that had a hand-rolled pseudo-random number generator, so you know it's good. Don't write your own crypto. Don't do that. But wrote their own pseudo-random number generator that included things like the current block hash, the current timestamp, and a few other things that they appear a little bit random, but they're not really. So people try to crack this thing because all the data is available there to compute what this seed would be for the pseudo-random number generator, and then they could predict what would show up in roulette, and they could bet, and they could win money. So initially people were playing games with trying to mine blocks in a certain order to cause a certain outcome, and they bet on that outcome. But a more succinct exploit for this was somebody just wrote a contract that computed the pseudo-random number generator seed in the same way, just made sure it made it into the same block, and then that contract would call into the roulette and would win because it knew what the answer would be. Anyway, kind of interesting, but yeah. So there's there's a growing number of security tools out there for auditing smart contracts. Our friends at Trail of Bits are going to release some any day now. I've been saying that for a bit. But no, they will soon. But a really cool one that's available right now is MythRoll. I used a few times for this. Parity is a EVM decompiler. And then there's a few static analyses / linters. But I'm sure I missed some. So anyway, this is a starting point if you're interested in doing some of this stuff. We'll move on here. Okay. So just a few words for how we're handling as Swarm, how Swarm is handling security. Go ahead. So we're going to have a bug bounty where people can try to find vulnerabilities in our smart contracts, and we'll pay them for that. And then in addition to that, again, we'll go ahead. We're going to have an actual audit. So that's what we're doing on our front. Again, our background is information security. So we're very familiar with the fact that we can make mistakes just like everyone else. Everyone makes mistakes. So we're going to try to find them as best we can. And I'm just going to blow through some slides here. Go ahead on what exactly Swarm is. So that's the end of the smart contract insecurity talk. And Swarm, we're trying to build a new threat intelligence market. Let's go ahead. There's some things wrong with today's market. We've got a Venn diagram here. So imagine the black is, or the rectangle is all of the different malware that an enterprise might face. And these circles are like Antivirus 1 and Antivirus 2. And those circles overlap a lot. They cover a lot of the same stuff. So ideally, they wouldn't overlap so much, and they'd cover more of the space, like this nice diagram I got there. And the way that we're doing that is we're programming Ethereum smart contracts to reward timely and accurate threat intelligence in terms of there's security experts crowdsourced around the world asserting whether or not they think a particular file is malicious or benign. And they're rewarded in our token. So anyway, go on. Let's just keep going. So if you're interested in the Swarm thing, I'm very happy to talk about it. It's a large market. We think it's ripe for disruption. Again, it's our background. So we'll go ahead again. Yep, go ahead. So just at a high level, the way that this works is we have a bounty mechanism and we have an offer mechanism, and you can think of a bounty as like a wild, wild west sort of bounty, where except on the poster, instead of saying like you want this guy dead or alive, you want a piece of malware exonerated or condemned, I suppose. So yeah, so there's end users or enterprises that submit files to ambassadors that interact with our smart contracts that security experts around the world can say whether or not they think they're malicious. So we'll go ahead. Let's skip that and that and that. And yeah, keep going. So the closest centralized equivalent of what we're trying to build is something called VirusTotal. You've probably heard of it. If you haven't, it's a service that you can go to and upload a file, and it scans the file against like 60 different antiviruses and tells you whether or not each of them think it's malicious. It's an extremely lucrative business. Each major player pays on the order of $160K per month for access to this thing. And in fact, Google bought VirusTotal a few years ago. So if you use Gmail, you're actually using VirusTotal on the back end when they scan your files when you're going to download them in attachments on Gmail or something. So go ahead. So it scans a lot of samples a day. We think we can do better. It costs a fair amount to scan each sample. Again, by decentralizing, we think we can do better. A little bit about our plan. So we're going to have a token sale in February, so not for a while, but happy to talk to anybody about that. Let's go on. So we're going to try to, again, our background's InfoSec. We know that industry. We're going to get a lot of security experts on board. We've also, just yesterday, McAfee published a blog post that spoke about us in a bullish manner. So that's great. We've been talking with their office of the CTO for some time now. They seem pretty interested about the thing, and we think they're going to be an early player in here as well. So we expect, the more traditional players as well as new players to participate in this market. So that speaks to that. Let's go on. And I could talk about that in person. Let's keep going. And then a little bit about us. One more. So if you're in the information security space, these would probably mean something. If you're not, then maybe not as much. But yeah, we've got some really good advisors, and we're reaching out to more blockchain-specific advisors right now. We're talking with a number of people, so we're just getting the word out right now and giving talks on security. And here's us. The light in these headshots is just way too bright, so we're like, it was like extremely painful. And I normally wear glasses, and that was also weird, but okay. So let's continue. So there we go. So I'm sure we missed some things that are really interesting. We'd love to hear from you guys. I'd love to chat about Swarm or smart contract and security in general. We just open sourced a framework for Ethereum distributed app development. It's called Perigord, which is a type of truffle. I had to Google that. But it aims to be the Go language equivalent of truffle, which is a JavaScript framework for developing Ethereum distributed applications. So check it out. It's also a place in France. We weren't going for that, but we were going for the truffle thing. So there you go. Thank you for your time.
So, do you have any questions from the group?
Sure. Yeah, so I was just wondering, in general, when it comes to different smart contract, coding languages, what kind of background is best to come from? Like, if you're someone who knows how to write code, like what languages tend to be the most similar? And are these languages only used for smart contracts, or are they used for other applications?
Great questions. So there's two answers to the first question. And so, yeah, I'll start at the first question. That makes sense. Yeah, so the original language to code Ethereum smart contracts was based around, it was trying to emulate Python, and it was named similar to Python. It was named Serpent. It wasn't quite Python, but it was trying to emulate some of the Python syntax. And the Serpent bugs are like even, there's, Serpent had a number of like compiler specific bugs that like, even if you coded the contract correctly, like it could still be a problem. And that's like a whole nother rabbit hole, but people have moved off Serpent to Solidity is what a lot of people use right now, and that's aiming to emulate JavaScript. It's not JavaScript, and to answer your second question, these compilers are not used for anything else. They compile down to the Ethereum virtual machine bytecode, and they're really just purpose-built for this. And what's being developed right now by Vitalik and some other core developers is something called Viper, and they're moving back to designing it to look like Python. I'm optimistic about Viper. I think they're doing a lot of things that are safe by default that they're not doing in Solidity. So, great question.
Which one did you say was emulating JavaScript? Or similar?
That would be Solidity is emulating JavaScript. Yeah.
Thank you.
Mm-hmm.
Other questions? All right, here we go.
What are your thoughts on the Neo platform implementing all these .NET languages? Is that a good direction to go, or is that just more of worse than this?
So I'll have to apologize. I'm not actually familiar with the Neo platform at all. Should I be?
Well, the general question is supporting general purpose languages like C# and VB.NET. Is that a good thing or a bad thing?
Okay. Yeah. So in terms of developing for Ethereum, right, as a front, yeah. So I don't think it's inherently a good or a bad. I think it's a good thing to get more people on board, and if people are more familiar with things like C++, great. That's actually, I think, why they moved to Solidity. They're trying to attract a lot of people that are like Web 3.0, whatever that means, sort of thing. So they knew JavaScript, so they developed this language around how JavaScript typically operates. I don't think you'd get anyone saying that they wouldn't be in favor of more front ends, more development languages. I don't see a reason why you wouldn't want that. At the end of the day, what's executed by all of the machines that are running the Ethereum network is the bytecode that's being produced anyway. So at the end of the day, it doesn't really matter what you coded in. So I guess in summary, the more front ends, the better. Some might lend themselves a little bit more to incorrect paradigms, but in general, I would say the more the merrier.
So my question is, I'm just kind of like a newbie, maybe like 6 months in. The whole thing about Bitcoin is like, people say like you don't need a third, there's no middleman or whatever, but the whole thing is like every time I get a transaction and I send it to another person, the miners are involved and they charge me a fee, and that fee is kind of expensive sometimes. So can you just cover that? I don't even know if that really makes sense, but just kind of, I've been thinking about that a lot.
Sure. So Ethereum also has miners, and Ethereum also has fees for transactions. Ethereum is trying to get to a state where they remove proof of work, which is why you have miners, and move to a proof of stake model. But the reason why you have transaction fees, and Bitcoin has gotten exorbitant, so people are working on that problem, but the reason why you have transaction fees is you need to convince people effectively that your transaction is more important than other people's transactions, right? There's got to be a reason for somebody to try to solve a complicated math problem effectively with your transaction in it, as opposed to other people's transactions that put up a larger bounty. So yeah, we're seeing problems in Bitcoin Core right now, moving funds around high transaction fees. There's a number of different solutions people are working. One in the Bitcoin space is called Lightning. The equivalent in the Ethereum space is called Raiden, but they're similar in a lot of aspects, and I can talk at depth offline, I think, on those. So that's, in general, you're referring to the scalability problem, I think it boils down to, and definitely a concern. There's some real cool stuff also happening in the Ethereum space. If you Google Ethereum Plasma, Vitalik and Joseph Poon, I believe, are the two authors on that. They have some real interesting ways to address some of the scalability problems on the Ethereum platform as well. So a lot of things happening in that space. It's tough right now, but yeah, a lot of things happening. So
I would like to come back to the last question about the different languages. So pretty much any language that allows threading or any type of modern multi or parallel processing is inherently not suitable for smart contracts, period. Why? Because it violates determinism. Determinism is probably the most critical aspect of any computational power on a blockchain. Why? Because you're requiring 100,000 nodes on Ethereum to come to the same conclusion at the end of a computation, right?
So I agree with you. Parallelism is a hazard for determinism, but I would come back and say that parallelism is already happening even without a language that explicitly supports threads. So one of the classes of vulnerabilities I didn't get into is inter-transactional race conditions. So that's actually currently a problem where if you do a critical thing like transfer funds to somebody and then subtract, but there's some good examples out there. You can race it. Okay, a good example is Alice wants to send Bob, wants to sell foo to Bob for 100 bar, whatever, ether, let's say ether. And then there's a third party, Charlie, that actually fixes the prices. So Alice says that she's going to do a put for 100 that she's going to sell to Bob. Charlie goes in, changed the prices to 300. Bob had already accepted the 100, but based on the ordering in the transaction, how it's mined, the different transactions in the same block, within the same block, there's race conditions. So if Charlie changes the price before it actually executes, like that's already a hazard. So I did a horrible job of explaining that, by the way.
If you get a majority to have that same ordering, right? It's less of a, it is a significant problem, but it's less of a problem if you allow, for example, for random numbers to be generated in your contract, or to have infinite loops, or have multi-threading. So that's when event 1 or thread 1 completes before 2,
Yeah.
that's a real problem.
I agree.
So I guess you guys are auditing contracts on the blockchain. Is that?
So we're not.
Oh, you're not.
Our friends are at Trail of Bits.
Okay.
But no, we're not. We just like to browse Bitcoin talk and like laugh. But no, we're actually doing in our day jobs. We break other people's code. We audit people's code. But in this, we're actually doing forward development as opposed to reverse engineering. So yeah, we're not doing the auditing right now. We're just trying to figure out how to not mess up the same ways other people have.
And I guess for the service that you were talking about, for the bounties and the offer, is there a reason why? Well, I don't know if this is obvious, but is there a reason why you're building it on the blockchain as opposed to like a centralized system?
Yes, and that's one of the slides I blew over. I actually have a blog post on that as well. I'll give you the 30-second. Okay. imagine a Venn diagram. You have a box, you have a rectangle that's all the malware. I said some of this before. And you have two antiviruses, and there are two circles, they mostly overlap. That overlap is duplicated effort. Two antivirus companies have to employ duplicated effort to write duplicated signatures because they're not incentivized to share intelligence. They're disincentivized, actually. So that duplicated effort means duplicated cost, and that's passed down to the consumer. That's problem one. Problem two is today's market doesn't really incentivize specialized knowledge. There's no antivirus for IoT. There's no antivirus for SCADA. There's very few for mobile. And the reason for that, I think, is pretty simple. It's a very difficult sales pitch to say that, hey, I know about this really specific malware family that you're also going to get, right? Like, the likelihood of overlap in a sales pitch is difficult to make. So today's market doesn't incentivize specialized knowledge. And third, it disincentivizes interoperability. Not that you ever would want to run, like, say, just examples. I mean, really, this is true of any of them, but you wouldn't want to run both Symantec and McAfee, right? So you can't get the combination of their coverage. It's not possible today. So what we're trying to do is commoditize and make interoperable by crowdsourcing and having, like, well-defined responses to whether or not files are malicious or not that anyone in the world can participate in a market sort of setting. So we hope to cover more of that rectangle.
I have a follow-up question.
Okay.
So just curious about, like, how you structure Swarm. So you build these protocols for creating the system. What is Swarm's involvement after you've kind of publicized this thing?
So Swarm Technologies is the company, would be funded to develop this thing by token sale. And there's some ongoing revenue opportunities there as well. It gets a little bit in the weeds, and I could talk to you offline about that. But in terms of being in the middle of enterprises having suspect files and security experts saying whether or not they're malicious, Swarm is not in the middle of that. We just author the contracts, and people take off and do this all in a decentralized manner. And to summarize how it works on the security expert side, say there's a file that was swarmed, swarm it, and two people say, hey, I think this file is malicious, and I think it's like Nectar is the name of our token. I think it's like 10 Nectar malicious. And then 3 people say it's benign, right? And so they put up some amount of Nectar. And then at a later time, the community agrees on whether or not that file actually was malicious. The people who bet incorrectly, not bet, it's not really gambling, but the people who asserted incorrectly, their tokens are paid out to the people who asserted correctly. So it's redistributing wealth from people who are wrong to people who are accurate and timely. So that's it in a nutshell.
I'm interested in your thoughts about the security of Salt Lending's smart contracts that will be coming available November 1st.
Salt Lending smart contracts. I actually can't speak to that too much. I'm not terribly familiar. I'm sorry. One of those many.
Salt will be speaking here next month, so you can ask them directly.
I'd love to utilize their services immediately. If it's secure.
I don't know.
I think that talking about the aspects of the security, like the security aspects of the experts, I think that's an important aspect. So you briefly touched on that. As far as the amount of what is there going to be sort of like a library built around the malicious code that is found, or to compare it against? Like, how are the experts going to be qualified as experts, and then what are they going to use to cross-reference to be able to make sure that what they are asserting is actually malicious or not?
Great question. So in terms of library in the sense of like a framework for participating in this market, that's definitely part of what Swarm would be funded to develop and release open source to the community for plugging into this thing. In terms of security experts establishing themselves as experts, the most straightforward way to do that is to just participate in public bounties, and their past performance based on whether or not they're correct or not on past bounties could be used as a sort of reputation score. So one thing that we did not build intentionally into Swarm is an explicit reputation calculation, because so there's three classes of participants. There's the ambassadors that interface the enterprises and the security experts. We expect the ambassadors, which are people like McAfee or new players, to run their own reputation sort of calculations and figure out who are the best experts for, say, particular types of files or particular files in like a particular region of the world. And they'll use our actually offer mechanism, different than Bounty, to contract directly with those experts and get their intelligence out. So to more directly answer your question, experts are always free to try to associate their on-chain identity with their real-world identity, and they might prove their expertise in other ways. But we expect a lot of these experts to remain pseudonymous, and ambassadors to just pick and choose and trust the opinions of experts that have proven themselves on-chain to be effective for different file types.
All right, let's give a big round of applause to Paul for All right, well, now's the fun part. Anybody who wants to talk can come up and do a pitch, or
you don't have to come up front. You can do it from where you're standing. I might need the mic. So, anybody?
Yeah, my name is Russ, and I own a business here in San Diego where we sell mailing lists, marketing lists, email lists. We happen to have a list we just got in of, I think it's 153 million Bitcoin users throughout the world. So if anybody's marketing to Bitcoin users, we've got a great email list available. So there's my business, list57.com, list57. If you want to be a spammer. Good? You good?
Hi,
Mine was in like
my name is Gabo.
Yeah.
From the beginning of this year, they created a company that we are installing ATMs for Bitcoin, which we call them BTMs. And we have already installed 4, and we have just signed another 4. So it's about 8, and we are increasing them. We are looking for locations in San Diego. We don't have any in San Diego yet. The locations are normally places where